Good day. This is me again, Tato. Your host today. Today we are going to continue with calculus, and we'll be doing what we call the chain rule. So, guys, chain rule is part of our differential equations. Okay, it's part of us differentiating. So, when you deal with chain rule is basically a function inside of a function, hence the word chain. Okay, so how do you deal with chain rule, whereas you can have, for example, a function in a function in a form of let me see. Okay, let me reduce this. Okay, can I reduce it to, yes, let's say you have something like f into g of x. So here you have a function g of x inside the function f of x. Okay, so when you deal with such questions, for you to differentiate their specific rules that you need to follow. For example, if there's a power rule, there's a specific rule that you need to follow. If there's an exponential rule, exponential function, you need to know the exponential rules, logarithmic rules, trigonometric rules, whether it's a sum or a difference, so you need to know the rule, product rule, and the quotient rule. Okay, so I'm going to have some few examples that are going to demonstrate some of these rules. In some examples, it will be the combination of certain rules. All right, so the first question that we have, we'll see it's question 1. We have y of x. The function y of x is equals to the cube root of the sine of the cube of x. Okay, this is our question. So right now the question says differentiate this. So the question will never tell you that use chain rule. As a mathematician or as an engineer, you have to know that use chain rule to solve this specific equation. Okay, so how do you differentiate this? You start from the outer function, you go inside until you reach the final term. Okay, so the y prime of x equals to 1 over 3 into the sine of the cube of x. Then here you are going to have negative 2 over 3. So what happened here, this is the same as sine x exponent 1 over 3 y sine exponent y over 3. This is the same as that. Okay, so now here we use the power rule to differentiate this part. So when you use the power rule, you bring your exponent in front of your function to be a coefficient. Then you say that minus 1. What was here minus 1, and you bring what was here. Okay, so right now we have taken care of the outer square root. We need to take care of this guy. Okay, so multiply. The inner function is sine, so when you differentiate sine, you're going to have cos. Okay, so we have cos of the cube root of x. Okay, now we have dealt with this one. We go inside this. So to go inside this, we use the same rule as this one. Okay, so we have 1 over 3 into x. The exponent of x, it's minus 2 over 3. Okay, so now when we differentiate x, you will get 1. So what we can do now is to simplify this. Okay, since this is a negative exponent, it goes to the denominator. So it goes to the denominator. Okay, firstly let me start with this one. 1 over 3 times 1 over 3, it's 1 over 9. So 9 will come to the denominator. So this is a negative exponent, so it will come to the denominator. So we are going to have sine this. So since it came down, it will be not negative but positive. Okay, yes, so it will be positive 2 over 3. Alright, so I dealt with this one. Now I'm coming to this term. So this term, it's positive, so it's going to be on our numerator. Okay, now this I multiplied already, then we got 9. Then I'm coming to this term, so multiplied by x. So since it's on the denominator, that negative fades away, so we have x exponent 2 over 3. So this is the solution when you differentiate that. Okay, so this is the first example of our chain rule. Now let us look at the second example that might look a little bit complex. Okay, so example 2 will be y of x. So we have our y of x equals to this x over x plus 1, okay, plus the cosecant squared of x plus over x plus 1. Okay, so now differentiate this equation. So even this one, we are going to use chain rule. Why? You have a specific function inside a specific function. Okay, even this this fraction, you have functions inside functions. Okay, so you can say you have a denominator, a numerator, both of them inside a specific function, and that function inside the outer function. Okay, so now y prime of x will be equals to, so when you differentiate this, okay, before I do this, let me share a certain scale with you guys. Okay, so when I differentiate trigonometric function, I have a mini lookup table. So it's 10 minus secant and secant. Then I have my cot, my negative cosecant, and the cosecant. Okay, so if I differentiate this, I'm going to get the product of the remaining ones. Okay, so if I differentiate this, I'm going to get the product of 10 and cosecant. Okay, now if I differentiate cot, I'm going to get the product of these two. So if I differentiate cot, I'm going to get something like this with a negative. Okay, and if I differentiate cosecant, I'm going to get the product of these two. Okay, so since our example right now deals with this function, we expect to see such. Okay, now let's see. So when we differentiate the first part of that function, we are going to have a y prime of x equals to what? Y prime of x equals to minus cot of x over x plus 1. Okay, then we are going to have multiplied by, because if you differentiate this, you get the product of the two, cosecant of x over x plus 1. Now we have differentiated this part. Okay, now we have to differentiate the inner function. So to differentiate the inner function, we are going to multiply again. So when you differentiate this, we are going to use what we call a quotient rule. Okay, so using quotient rule, firstly you have x plus 1 squared. This is what we have, x plus 1 squared. Now you leave the denominator as it is. Okay, so you leave the denominator as it is. So here you have x plus 1 multiplied by the integral of the numerator. So I'm not the integral, but the prime of the numerator. So x prime is 1. When you differentiate x, you're gonna get 1. So the denominator is unchanged. Then you multiply it by the differential of this. So we are going to have 1 minus. Now you differentiate this, the denominator. If you differentiate this, you are going to get 1 multiplied by the numerator as it is, of which is x. So this entire thing here, it's x plus 1 multiplied by 1, so it doesn't change, minus 1 times x minus x. So at the end of the day, x cancels negative x, we have 1. Okay, so the entire part here concludes to 1. Alright, let me do it correctly. Okay, so this entire part here results to 1. Okay, so now we are done with the first part of the question. We are done with this part. Okay, now we're gonna put a positive sign and deal with this part. All right, so flip. Okay, I don't know what's wrong with my thing. Okay. Alright. Sorry about that. Okay, so right now we are going to write the second part. Right, let me use a different color, guys, so that you can see the second part. Let me see the thickness of this. To 2. Alright. Okay, so now it's all of that. I'm sorry. It's all of that plus the differential of the second part. Okay, so the second part is a power of 2. So we firstly need to use power rule to that. Okay, so we are going to have 2. Then the second part was it was not a sine but a cosecant of x over x plus 1. So the squared, we did power rule, we made the 2 the coefficient and said 2 minus 1, hence there's no power. Alright, so we're done with the power. Now we differentiate the outer function that's remaining, which is the cosecant. So now multiplied by, if you differentiate this, this is the same. Can I go up a little bit? Now we are done with the power, we are left with something like this. Okay, it's here. So now if you differentiate this, you are going to have everything you have here. Alright, you are now, if you differentiate what we have here, you are going to be left with what we wrote in black here. So now multiplied by what? Negative. I'm going to write it here, cot of x over x plus 1 multiplied again by the cosecant, this is cosecant of x over x plus 1. Now everything divided by x plus 1 squared, because everything multiplied by 1 over x plus 1 squared, everything becomes the numerator. Okay, so right now let me write again in black. I will try to simplify it. So right now we are going to have y prime of x equals to I hope it doesn't take a lot of space, equals to a negative cot of x over x plus 1 multiplied by the cosecant of x over x plus 1. Okay, now plus the negative of this, so negative and minus will result in a negative. Now cosecant multiplied by cosecant, we have a cosecant squared of x over x plus 1. Now we are only left with cot. The cot of x over x plus 1. So squared. Okay, so now this becomes the solution to that differential equation. Okay, so now we have the next question, and of which will be the last of this video. Now this one includes exponential function and logarithmic functions. Okay, so we have dealt with questions that have a positive or negative, addition and subtraction. We have dealt with trigonometric functions. We have dealt with a quotient and a product. Okay, so right now we are going to have this question: y of x equals to e exponent x, the ln of x, plus ln into the ln of x, okay, plus ln into ln of x over x, plus this is a very long question now, the ln of ln of x. So by the way, ln means natural logarithm. Okay, that's the full word of that. Now let us differentiate this. I'm so rushing into integration, I don't know why. Now the differential of this will be y prime of x, which is equals to, now when you differentiate e, the exponent of something, it remains the same. Okay, okay, so now this will be e exponent x ln x multiplied by, now we are differentiating this. Okay, so the differential of that, it's a product rule. We have a function of x multiplied by the function of ln x. So when you use a product rule, what do? You differentiate one function and leave the other one as it is. So if you differentiate x is 1 and leave ln as it is. So differentiate x and multiply it by the other function as it is. So ln of x, we leave it as it is. So it's 1 multiplied by ln of x, of which is ln of x. Now plus, we leave x, okay, we leave x as it is, it's x. Now we differentiate ln of x. So if you differentiate ln of x, you are going to get 1 over x. So x multiplied by 1 over x, it's x over x, of which x over x gives us 1. So everything here now reduced to 1. Okay, now we are done with this one. We move on to the next one. Plus, now if you differentiate the outer ln, you have 1 over the inner function. So we are going to have 1 over ln of x. That's you differentiate the outer ln. Now we are differentiating the inner ln. When you differentiate the inner natural logarithm, it's 1 over its argument. So its argument is x, so it's 1 over x. Okay, so we are done with this one. Now it's plus. Now we move on to this function. Now there's no space, so I will move it to the side. So right now, if we differentiate this, we are going to have 1 over the brackets. Okay, so 1 over ln over x, it will be 1 over ln x over x. So this will be x over then x. Okay, multiply. Now we differentiate this. So with this function we are going to have a product, the quotient rule. The quotient rule says you square the denominator, then you bring it here, and you differentiate what is the numerator. So if you differentiate the ln of x, you are going to have 1 over x minus, now you put what was there, the numerator, you differentiate the denominator. So the differentiate the x over the y here will be 1. If you differentiate x, you are going to have 1. Okay, so all this multiplied by 1. Now we are done with this one. So now the last part. Okay, so the last part, which is this one, we put that addition, this addition here, we put it there. Okay, now every time when you see ln, it's 1 over whatever inside the bracket. Okay, so when you differentiate this, you put 1 over everything inside the brackets, ln into ln x multiplied by, now we go to the inner ln, it's also a ln, so it's 1 over everything in its brackets, of which it's ln x. Now we go to this ln, it's also a ln. So you do what? You put the 1, okay, it's a multiplication, it's 1 over what inside its bracket, it's x. You go inside the bracket of ln, you differentiate it, it's x. If you differentiate x with respect to x, you get a 1. So now we are done. We're supposed to simplify. Okay, so you can simplify this thing further or leave it as it is. Okay, so to differentiate, to simplify what we already have further, I will say this now will be equals to now I'm going to have x ln x as my denominator here. Here my denominator, it's also x ln x, because this x will cancel 1x here. Then now no, this doesn't have shared denominator. Okay, so what I'm going to do, I'm going to make a very big fraction. So to make a very big fraction, I will do this. So it's x ln x. Okay, so now I have to just put this here. I can just multiply out, but it's gonna cause problems for me, like complicated. Remember, my aim is to simplify into the ln of x plus 1. Okay, oh wait, let me see. No. I made a mistake, guys, because I thought this is a multiplication. Okay, it's an addition. So this term is to just, I have to leave it as it is. So to leave it as it is, equals to, so now we have e exponent x ln x, so multiplied by ln of x plus 1 into the bracket plus, now we have x then x, so the numerator is 1. I'm just gonna leave it and come to this one here. Okay, so now this x will cancel the squared, so the denominator also becomes x ln x. Okay, now this will result to 1 because it's x multiplied by 1 over x. It would be 1 minus the ln of x. Okay, now plus, I'm done with this, I'm done with this, I'm done with this. Now plus the last part. Okay, now the last part will be 1 over multiplication of these two, it's x ln x, then this ln of ln x. Okay, so this is the final solution. Okay, it doesn't want to zoom out a little bit. Okay, yes, and this thing here is the final solution of this particular problem. Okay, so guys, those are the techniques of solving your chain rule. Now I have a challenge. I have a challenge. So based on the skills you have learned here, the challenge is solve the differentiate the following. Okay, so we have f of t equals to the square root f of t is equals to the square root of t squared plus 1 squared plus the square root of 1 plus t squared plus 1. Okay, so this is your challenge. Now let me put a second one. Okay, the second one, you have y of x equals to ln of the secant of x sine x plus natural logarithm of sec x plus sine x. Okay, so now this is the challenge. Okay, so as a practice, solve these two equations. All right, now just hang in there and wait for the next video. Okay guys, now do not forget to subscribe, like the video, and share it with your peers. Cheers guys.